I am Ankesh Patel from Bhakti International School, and today we are going to teach from standard number 9, chapter 1, it is number system. So, in the previous standard, you can learn about the different things of number system. So, in the last 7 or 8 class, you are familiar with that number line. So, in a number line, what happen? If we have so I am taking the one of the number line. So, in between they have a 0, and on the right hand side we have the number of like 1, 2, 3, 4. So, it means it is a positive numbers, and from left hand side we have the negative numbers like 1, -1, -2, -3 like that. Second, so according to that number line we are define the different kinds of the number or types of the number. So, first of all we can take the basics of your chapter. So, in standard number 9, in the exercise number 1.1 we have different kinds of the number. So, first of all we can take the introduction of that the number system, and then we are starting your exercise number 1.1. So, first type of the number, it is called natural number. So, natural number, it is denoted with n because it is starting from n. So, we are denoted with n. So, it is starting from 1, 2, 3, 4 onwards. So, we are taking the numbers of lakh, crores. Second type of the number, it is called whole number. So, in a whole number what happen? It is starting from 0. So, 0, 1, 2, 3 like that, and it is denoted with W. Third type of the number, it is called integers. But before that I have a question for you. So, if you know that what is the difference between natural and whole, so you can clearly see that the difference between whole and natural is starting from 1 and whole number is starting from 0. So, that is a basic difference. In whole number we are taking 0, in natural number we are starting from 1. So, it is a basic difference between both of them. Third, that is called integers. So, in standard 6 and 7 you are taking the different kinds of the properties of integers like addition, subtraction, multiplication or division. So, you are familiar with the integers. So, in an integer what happen? We have two types of integers. So, like 0, 1, 2, 3, 4 like it is called positive integers, and -1, -2, -3 it is called negative integers. So, in a integers why they are denoted with z? So, the reason in your book it is given. So, why it is denoted with z? So, one of the mathematician from German, that is called Zeller, they are invented that number. So, so integers is denoted with z because Zeller invented that number. Fourth type of the number, it is called rational number. In standard 8 we have one chapter like rational number. So, we have the one definition for that. So, natural number are those number which is in a form of p upon q. So, we are taking the one of the example, so you can get the idea what is called rational number. Suppose I am taking one example of rational number. If we are taking 1, 2, 3, so these are the all rational number. Why? If we are taking 1 upon 1, so it is called p by q form. If we are taking 2 upon 1, so it is also called p upon q form. So, it means what? Rational number are those number which is in a form of p upon q. So, here p is equal to 1 and q is equal to also 1. In second case p is equal to 2 and q is equal to 1. Or also we are taking some different example like 3 by 4 or 4 by 5. So, these all are the rational numbers. So, rational number are always denoted with p upon q form. And then the next number it is irrational number. So, in a irrational number what happen? It is exactly opposite to the rational number. In a rational number they are in a form of p upon q, but in a irrational number the number which is not in a form of p upon q, so it is called irrational number. So, what are the example of irrational number? So, we are taking the example of irrational number. Suppose √2, √5 or 2.131415 like that. So, it is all called irrational number because we cannot convert that number into the p upon q form. So it is called irrational number. So this up to this, that is a basic of the number system, and up to that all number we can also introduce in the previous standard, but that two numbers are different. First it is called prime number, and second it is called composites number. So in a prime number what happen? So the number who is divisible with the number itself. So it means what? Suppose we are taking the example of prime number. Suppose it is starting from 2, 3, 5, 7, 11, 13, 17, 19 like that. So this all number you can see. So 2 is divisible with 2 only, or 2 is also divisible with 1. So it means what? The number who is divisible by number itself, or it is divisible with 1. So this number are called the prime number. So suppose these all are the prime number, because these all number are divisible with number itself or 1. So no other factor than the number and 1. So it is called the prime number. So second and next, so it is called composite number. In a composite number what happen? So in a composite number, the number have more than 2 factor. It is called composite number. So what are the example of that composite number? Suppose we are taking one of the example for it. We are taking 4. So what is the factor of 4? We can write 2 2s are 4 and 4 1s are 4. So factor of 4, it will be 1, then 2 and 4. So it have the more than 2 factor, because it have the 3 factor 1, 2 and 3. So the number have more than 2 factor. You need to remember that one term only. The number have more than the 2 factor. It is called the composite number. So we are taking the one more example, so you can get the idea. Suppose we are taking the 16. So in a 16 what happen? So first of all we can take its factor. So 16 1s are 16, then 8 2s is also 16, 4 4s is also 16. So here what are the factor of that number? 1, 2, 4, 8 and 16. So they have the more than 2 factor, because it have the 1, 2, 3, 4 and 5 factor. So it is called what? Composite number. Composite number have always more than the 2 factor. So that is, both are opposite to each other. In a prime what happen? They have exactly 2 factor, and composite what happen? They have the more than 2 factor. So you need to write the all the basics of that chapter. Take a screenshot of that board, and then you can write down that before the starting of that chapter. So you can get easily the idea what are the number system. So first we can take the different kind of the number system, but in exercise number 1.1 we are starting from that number only, rational number. So before starting the rational number, you need to remember that definition. Clear? So the number which is in a form of p upon q, it is called rational number, and second it is irrational number. The number who is not in a form of p upon q, it is called the irrational number. So we can learn the number system. So according to our that topic, we have taking the sum of the true false according to that. So first, every whole number is a natural number. So you know that. First of all, I am drawing the one of the number line, so you can get easily that idea. It is 0, 1, 2, 3 and -1, -2 and -3. So we know that all number is starting from 0, all number is starting from that, and natural number is starting from 1. So every whole number is a natural number? No. Why? Because all number is starting from 0 and natural number is starting from 1. So it is what? False. So what is its reason? Because 0 is included in a whole number, but 0 is not included in the natural number. Second, every integer is a rational number. So it is called integers. Suppose that is called positive integer and that is called negative integer. And we also know that the definition of rational number. So rational number are those number who is in a form of p upon q. So it is called integer. So now how we convert that integer into the rational number? Suppose we can write like that. So it is in a p upon q form. It is also p upon q form. So this all number we can write p upon q form, because answer will be remain same, -1 upon -1, answer will be -1, but it is in a form of p upon q. So second, every integer it is a rational number, it is true, because we can convert all integers into the rational number. Now third, every rational number is an integer. No, because suppose we can take the one of the example, so you can get the idea. I am writing a one of the number 3 upon 5. So 3 upon 5, what happened? It is rational, but it is not an integer. So in a rational number, what happened? We can write 3 by 5, but it is not included in the integer. Why? Suppose we can divide with that. So here it is lesser, so here we can put 0. So here we have a point, and 5 6 it will be 30. So what is its answer? 0.6, and 0.6 is included here, but 0.6 it is not an integer. So third statement, it is false. Now fourth, every natural number, every natural means it is starting from 1. It is a whole number. Yes, because natural number is starting from 1 and whole number is starting from 0. So every natural number is included in a whole number. So that statement is true. Next, every integers is a whole number. False, because in an integer we have two types, positive integer and negative integer. But in a whole number, what happened? It happens starting from 0 only. So they are not including the negative integers. So that statement is false. Every integer is not a whole number, because whole number is starting from 1, but integers included both positive as well as negative integers. Now last, every rational number is a whole number. So every rational means what? We can take any of the example, but in a whole number, suppose we can take the one example. I am writing like that, -3 upon 5. So answer it is -0.6, because we can already perform that division. So answer is -0.6, but so it is rational. It is rational number, but it is not included in a whole number, because in a whole number it is starting from 0. But in a rational, it is also the negative value. So that statement is false. So first three, it is take from your solve sum number 1. Solve sum number 1, it is given in your book. And last 3, 4, 5 and 6, it is your exercise 1.1 last question, question number 3. They are saying identify it is true or a false, and if it is false, give the reason. So in that you can give the reason. Every integer is not a whole number, because in a whole number it is starting from 0, but integer they are also including in the negative as well as the positive value. Now we are going to start our exercise number 1.1. So in exercise number 1.1, what happened? We have one question. Question number 1. Is 0 a rational number? First question, 0 is a rational number or not? So yes, it is a rational number. Yes, 0 is a rational number. But how? I am saying that 0 is a rational number, but how? Because it is not in a p upon q form, but we can write like that, 0 upon 1, 0 upon 5. So it is p upon q form. Answer will be remain 0, because if we write 0 upon 1, answer will be 0. So but it is in a p upon q form. So we can say that yes, 0 is a rational number, and we can write 0 in a p upon q form. So we can say that yes, 0 is a rational number. So exercise 1.1, we can already question number 1, 0 is a rational number. Now we are going to start our question number 2. So in a question number 2, first of all we can read that question. Find the 6 rational number between 3 and 4. So for we have a 2 different method, but we can start with our easy method. So first of all I am drawing the one number line. So it is 0, 1, 2, 3, 4, 5. So we need to find the rational number between these two, between 3 and 4. So here we have a infinite number between 3 and 4, like 3.1, 3.11, 3.112. So we have the infinite number between 3 and 4, but we need to find only 6 rational number. So we are starting. Suppose we can write 3 and 4. Then how many I want to find out the rational number? 6. So we can add 6 plus 1. So we have a 7. So now we are multiply with 7 and divide with 7. We can also perform with 4. So 7 3s are 21 and 7 4s are 28. So between 21 and 28 we have a number like that: 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. So this is our answer. We have a 1, 2, 3, 4, 5 and 6. We need to find the 6 rational number. So we have so answer is the 6 rational number between 3 and 4 are 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7 and 27 by 7. So it is its method. Once again I can repeat that method. First step is what? If they are asking 6, so we can add, so 6 plus 7. But in some example, if they are asking 4, so we can add 4 plus 1. So first step you can add 1, and then suppose you need to find the number between 3 and 4. So first of all we can write 3 and 4. Then we are multiplying and divide with 7. Again we are multiplying and divide with 7. So 7 3s it will be 21 and 7 4s it will be 28. So between 21 and 28 we have how many numbers? 22, 23, 24, 25, 26 and 27. So these are the 6 rational number between 3 and 4. In some cases they are also asking like that. Suppose find the 4 rational number between 0 and 1. So we have the same method. Suppose they are asking how many rational number? 4. So first we can write like 4 plus 1. So it will be 5. Now we want to find out the 4 rational number between 0 and 1. So first of all we can write 0 and 1. Now we are multiplying with 5 and divide with 5. Here once again we can take the same procedure. 0 multiply by 5 and divide with 5. So 0 upon 5 and here 5 upon 5. So between 0 and 5 we have how many rational number? 1 by 5, 2 by 5, 3 by 5 and 4 by 5. So these are the 4 rational number which is present between 0 and 1. So it is its extra example. Now we are going to start our question number 3. So in a question number 3 they are asking find the 5. How many rational number we want to find? 5. So find the 5 rational number between 3 by 5 and 4 by 5. So we want to find out how many rational number? 5. So first step is 5 plus 1. So it will be 6. Now we want to find out the rational number between which two number? We can write 3 by 5 and 4 by 5. Now we are multiplying with 6 and divide with 6. Once again we can multiply with 6 and divide with 6. So what is its answer? 6 3s are, it will be 18, and 6 5s are 30, and 6 4s are 24, and 6 5s are, it will be 30. So between 18 and 24 we have how many rational number? 19, 20, 21, 22, 23. So these are the how many, how we want to find out the how many rational number? 5. So 1, 2, 3, 4 and 5. So we can write like that: the 5 rational number between 3 by 5 and 4 by 5 are 19 upon 30, 20 upon 30, 21 upon 30, 22 upon 30 and 23 upon 30. So this is our second topic. It is we can represent the irrational number on a number line. So first of all you need to remember what is irrational number. So irrational number are those number which is not in a form of P upon Q. So irrational number are those number which is not in a form of P upon Q. Suppose we are taking the example of that root 2, root 5, root 7. So these all number are called irrational number because we cannot convert that number in a P upon Q form. So how can we represent that number on number line? So it is called our number line. So here we have a 0, then 1, then 2. Here we have a minus 1. So it is called our number line. Now I want to represent root 2 on a number line. So for that you need to remember one basic theorem. It is called Pythagoras theorem. It is actually come in your standard 10, but here we haven't the one application for that, so we can learn its basic. So according to the Pythagoras theorem, so it is called right angle triangle. So in a right angle triangle, one of the angle it will be 90 degree. So we can give its name A, B and C. So it is called its base, it is called its hypotenuse, and it is called its altitude or height. So according to the Pythagoras theorem, they are saying that AC square is equal to AB square plus BC square. Also we can write like that: hypotenuse square is equal to base square plus height square. So here we can use that theorem. Once again I can explain that. Suppose we have the right angle triangle. So opposite side of a 90 degree, it is called hypotenuse. So it is a 90 degree. So opposite sides of that it will be AC. So AC square is equal to base square plus height square. So base it will be AB, and base it will be height it will be AB, and base it will be BC. So we can write like that: hypotenuse square is equal to base square plus height square. Now we can take the one example, so you can get the idea how can we represent the any of the irrational number on a number line. So it is our question: represent the root 2 on a number line. So for that we can take we can draw the, first of all, we can draw the number line. So on a number line, we want to represent root 2. So for that, here we can take base is equal to 1. So first of all, we can draw that base is equal to 1. You can take any of the scale on number line, either 1 centimeter, 2, or it is depend on you. And that will be, height is also 1 centimeter. So here we can draw the same measurement. If it is, here it is in the 15 centimeter. So we can also draw the one of the 15 centimeter line like that. Now we can join that 2 point. So it is called our right angle triangle. See, it is called right angle triangle, and here we can give its name. Suppose it is A, that is B, and that is C. So it is called a one kind of the right angle triangle. So now we can apply the Pythagoras theorem and that. So if it is 1 and it is also 1, so we can write base is equal to 1 square and height is equal to also 1 square. So 1 square is 1, and once again 1 square is 1. So answer it will be 2. So here we can write hypotenuse is equal to 2. Now, so what is the hypotenuse now? It will be AC. So AC square is equal to 2. So now we are taking the square root both sides. So if we are taking the square root of AC, so it will be only AC. And if we are taking the square root of 2, so it will be root 2. So now I want to draw that on a number line. So first of all, we can take the point on A, and then we can take the arc up to the AC, and then we can draw the one of the line like that. So here it is intersecting on our number line. So this measurement, it will be root 2. So it is a basic of that. We can represent any of irrational number on a number line by using the Pythagoras theorem. Stop.